Right, in this video we're going to look at the calculations that you really need to be on top of when you start your A-level course. First of all, we've got to remember we're talking about typically masses, moles and things like that. Now the first thing you need to know, relative atomic mass. And it has the symbol AR, and it's always given to you on the periodic table for every element. Now, some people often ask, what's the difference between relative atomic mass and mass number? The mass number is always exactly a whole number, because mass number is the number of protons and neutrons in an atom. But relative atomic mass is effectively an average of these, because, of course, elements can exist as different isotopes. So the relative atomic mass is the average of what an atom weighs, and we compare it relative to other atoms, because obviously the actual mass of an atom is tiny, and we compare everything relative to carbon that weighs 12. Now it doesn't really matter too much that the fact that we compare it to carbon, it's just that on that scale that carbon weighs 12, we've got hydrogen that weighs 1, okay, I said carbon weighs 12, oxygen weighs 16. And those are just some examples of relative atomic masses. And then relative formula mass, known as MR, is calculated very simply by just adding the relative atomic masses together. So if I said, what's the mass of C2H6O, the relative formula mass, it's got 2 carbons, so 2 times 12, plus 6 hydrogens, 6 times 1, plus oxygen weighs 16, add those together, you've got 44. And there we are, that's how we work out relative atomic mass. Remember that occasionally you'll see molecules, formulae, which have got brackets in them, don't forget. So for example, if I said MgOH twice, now Mg has an AR of 24, so MgOH twice, it's 24 plus, in brackets, you've got 16 plus 1, and you've got a 2 outside the bracket, so you multiply it by 2. 24 plus, that's 17 times 2, and 17 times 2 is 34. 24 plus 34 equals 58. So that's how you work out relative formula masses. More importantly than that is the concept of the mole. And it's no good knowing the mass of something if we don't understand what moles are. Now, 1 mole happens to have the same number of particles as there are in 12 grams of carbon-12. Now, why is that number important? Well, 1 mole of anything has the same number of particles of that thing. 6.02 times 10 to the power 23 happens to be the number. But it's a bit like in everyday life, the word dozen means 12. The word mole means 6.02 times 10 to the power 23. And we choose that number, it seems a very odd number, because it just so happens that that number of carbon atoms weighs 12 grams. So 1 mole of carbon weighs 12 grams. And as I said in the previous bit, carbon has a relative atomic mass of 12, 1 mole weighs 12 grams. And that's the same with any element. 1 mole of, let's say, magnesium weighs 24 grams because its relative atomic mass is 12 to 24. Now, oxygen, 1 mole of O2, oxygen, of course, going around in pairs, because oxygen's relative atomic mass is 16, 1 mole of O2, 32, is 32 grams. So 1 mole of anything basically weighs whatever its relative formula mass is in grams. And that's useful. Now, supposing we haven't got 1 mole, supposing we've got 5 moles. Well, there's a simple equation which says the mass of something is the relative formula mass times the number of moles you've got. Now, some people like to remember this as a triangle. Mass, MR, and moles, and all 3 things there begin with an M, so it might help you to have a little way of remembering it. The way I remember it is massive Mr. Mole. Just think of a giant black creature tunnelling its way, ruining your garden, your lawn. Massive Mr. Mole is one way of remembering that little triangle. Put it another way, the number of moles, if I look at the number of moles, is the mass divided by the MR. And that is a very common version of the equation. We're going to be using that moles is mass over MR quite regularly. The most important calculations we have to do using the massive Mr. Mole equation are what we call reacting masses calculations. And they basically are those that tell you or ask you things like, how much calcium oxide can I make from reacting 10 grams of calcium carbonate or something like that? So in those questions, you're always given a balanced equation. And let me just take that equation as an example. Calcium carbonate makes calcium oxide plus CO2. What mass of CaO can be made by heating 10 grams of CaCO3? And at a GCSE level, you're always given the AR values. Calcium is 40, carbon 12, oxygen 16. Now at A level you have the periodic table, but you've got to work it out for yourself that you need to look at your periodic table, whereas at GCSE they always give the data in the question itself. So what do we do? Well, here's how I would approach it, and you may have your own method of doing this, but this is the method I use, and I tend to write things out directly under the equation. Right. First of all, I'm going to write the MR of the relevant substances. Calcium carbonate. Calcium is 40, carbon is 12, that makes 52. 3 oxygens, 3 16s are 48. 52 plus 48. Calcium carbonate weighs 100 MR. Calcium oxide, 40 plus 16, is 56. Now I'm going to do this calculation the way I would do it. Having worked out the MR, I then work out the moles. Well, I'm told in the question I have 10 grams of calcium carbonate. So I have to work out the moles, mass over MR, 10 over 100, which is 0.1. Now, if I start off with 0.1 moles of calcium carbonate, this equation has no numbers in front of the reactants and products. 1 calcium carbonate makes 1 calcium oxide. That means a mole of calcium carbonates would make a mole of calcium oxides. So 0.1 moles of calcium carbonate would make 0.1 moles of calcium oxide. So I know my moles of calcium oxide. So if I know my moles of calcium oxide, I can work out my mass. By the way, this step, I sometimes just use the word stoichiometry. Stoichiometry is all about the ratio of reactants and products in the balanced equation. And in this example, it's 1 to 1. So if I start off with 0.1 moles, I end up with 0.1 moles. Now, we know from our triangle, massive Mr. Mole, mass is MR times moles. And we're trying to find the mass of calcium oxide. So I need the MR of calcium oxide, 56, times by the number of moles, 0.1. 5.6 grams. And that is the simplest sort of reacting mass calculation. Slightly more complex is when the stoichiometry is not 1 to 1. So let's take an example of, I'm trying to think of a simple one to do. Let's go for methane gas plus 2 molecules of oxygen makes CO2 plus 2H2O. And let's say the question is calculate the mass of water. Oh no, let's go for the mass of oxygen needed to fully burn. And I'm going to say 3.2 grams of methane being CH4. Okay, so there's a typical exam question again. This time we're asking how much oxygen would I need to fully react 3.2 grams of methane. So as before, I would write out the MRs of the relevant molecules underneath them. Methane, carbon, just to remind you, the AR values, carbon of course is 12, hydrogen is 1, oxygen is 16. So methane is 12 plus 4 times 1, 16. Oxygen O2 is 32, but there are, okay, oxygen is 32. We'll come back to the fact there's 2 of them. So, these are our MR values. Now, my mass of methane is 3.2 grams. So my moles of methane is the mass, 3.2, over 16. Put it into your calculator. If you can't do it in your head, that's 0.2 moles. This one, oxygen. Now, stoichiometry this time. There's no number in front of methane, but there's a 2 in front of oxygen. So if I start off with 0.2 moles of methane, I'm going to need twice as many moles of oxygen. So I need 0.4 moles of my O2. Now the MR of oxygen is 32. So my mass, massive Mr. Mole, MR times moles, is 32 times 0.4. Put that into your calculator and you get something like 12.8 grams. And that's your answer. 12.8 grams of oxygen is needed to completely react with 3.2 grams of methane. So this step, where I went from 0.2 moles of methane to 0.4 moles of oxygen, that's my stoichiometry step. And you've just got to keep an eye out for that in your equation. 1 reacts with 2. Or 2 reacts with 3, or 5 reacts with 4, or whatever the stoichiometry in your balanced equation is. And those are the most important types of calculations that you need to be familiar with before you start your A-level.